Hi, good morning, friends. So, in our sixth lecture of environmental engineering, we are going to discuss about certain process. So, first of all, welcome to Just Get Civil, and we are going for Mission Gate 2021 crash course regarding environmental engineering. Myself, Soumyajit Sen, and before going to the details of the topic, just telling you that अगर आपके पास अभी भी अनअकैडमी का लर्निंग ऐप ना हो, प्लीज जाइए अनअकैडमी इसका प्ले स्टोर में and you if you click the type there for an academy learning app, you will get the thing. आप install कीजिए, install there, and when you click for your choice of course, as it is a gate and EAC, I have sourced there gate and EAC. Then go for Unacademy Plus, जहाँ पे आपको मिलेगा top most educators का classes, personal mentorship process, and you can go for the subscription also. सब्सक्रिप्शन लेने के टाइम पे दोस्तों हमेशा याद रखिए, प्लीज यू प्लीज अप्लाई सब्सक्रिप्शन टुडे itself. Please apply the code SEN10, you will directly get 10% discount. ACN10, please remember this is my code, ACN10 SEN10. Now, there is a good news for GATE 2022 aspirant students. You can say it's a New Year gift to you from Unacademy. We're starting a batch in English and Hindi on 28th December 11:15 a.m. We're starting a batch for GATE 2022 on 28th December 11:15 a.m. and topmost educators are there. Subscribe today itself. Go for, and when you are subscribing, don't forget to put this code 1010 in the subscription process. You will get directly 10% discount. Don't forget to apply this code. And this particular batch will those who are aspirants for GATE 2022, I will suggest you to don't be late. Just go to the Unacademy Learning app. Go for and app subscribe this particular for the enroll yourself for this channel or for this particular course. Get 2022 will be ours, and eventually we will crack it together. We will do it better. Now, let's continue the discussion of our courses. Whatever is going on, and generally we have started that previous chapter, and physical water quality parameter has completed. Then we have completed the chemical water quality parameter, and also we have completed. Now we are entering to biological water quality parameter. We will quickly finish the biological water quality parameter, and then we will go for the treatment process, then sedimentation process. That so here, that is a topic for main topic for today. But before going to the plain sedimentation process, we want to finish this biological water treatment biological water quality parameter chapter means that's part of quality of water. So till today, we have observed that we are actually done with the when we have entered the quality of water. हम लोग जब quality of water chapter में enter किए थे, तो हम लोग आपसे इतना डिस्कस हुआ था कि नॉर्मली क्या होता है कि प्रोसेस में जो क्वालिटी चेकिंग क्या कब होता है, एक बार होता है ट्रीटमेंट के पहले, एक बार होता है ट्रीटमेंट के बाद. ट्रीटमेंट के पहले वाला जो क्वालिटी है, वो क्वालिटी में वो जो ट्रीटमेंट कैसे होगा, कैसे होना चाहिए, क्या क्या चीजें ट्रीटमेंट यूनिट में बैठना चाहिए, वो सारी चीज के ऊपर डिस्कस किया जाता है, वो सारी चीज को जांच किया जाता है. और ट्रीटमेंट के बाद वाला जो क्वालिटी है, उसमें आप नॉर्मली क्या होता है कि वो सारे चीज को देखा जाता है कि भाई अब आपका ट्रीटमेंट यूनिट जो है वो सही से काम कर रहा है कि नहीं, वो लागू है कि नहीं ढंग से. अब इस प्रोसेस में सबसे बड़ा पॉइंट जो है दैट इज ये जो क्वालिटी ऑफ वाटर वाला पार्ट है, एंड दिस क्वालिटी ऑफ वाटर इज एक्चुअली डिफाइंड इनटू थ्री ग्रुप्स according to their state, that is physical water quality parameter हम लोग देख चुके हैं, color, taste, odor, turbidity, etc, temperature. जो वाटर क्वालिटी पैरामीटर हम लोग which is actually uh, can be identified by human senses, and they are not detrimental to the human being. बट what else, बट क्यों हम लोग फिजिकल वाटर क्वालिटी पैरामीटर के लिए पीछे भागते हैं, क्यों हम उसको हटाने का कोशिश करते हैं? क्योंकि फिजिकल वाटर क्वालिटी पैरामीटर्स आर रिमूव्ड फ्रॉम वाटर फॉर द एस्थेटिक व्यू ऑफ द यूजर्स, मतलब आदमी का दिमाग में जो चीज है उसके ऊपर फिजिकल वाटर क्वालिटी पैरामीटर को देखा जा सकता है कि एस्थेटिक व्यू ऑफ द यूजर्स के ऊपर चलता है कि भैया दिमाग में बैठा हुआ है चीजें, तो इसीलिए सही करना पड़ता है. Now, if you go for the chemical water quality parameter, we have discussed in the last class yesterday. First of all, we have gone for this the discussion of solids. We have seen the measurement techniques. We have seen that what are the process of measuring the solids and what are the limits drinking water standards. Then we have gone for electrical conductivity. Thirdly, we have gone for pH, acidity, alkalinity, hardness, and what we can say that then we can after the hardness we can go for chloride, then sulfate, then or dissolved oxygen, fluoride, nitrogen content, and we have seen that different human induced or naturally present toxic chemicals in water and their limits. So after be gone for the chemical water quality parameter, now we are entering to the बायोलॉजिकल वाटर क्वालिटी पैरामीटर. अब बायोलॉजिकल वाटर क्वालिटी पैरामीटर का मतलब होता है कि भैया पानी में बायोलॉजिकल पैरामीटर मतलब जो पैरामीटर से आपका जो जो एक्चुअली द व्हाट इज द प्रेजेंस और एक्सटेंस ऑफ प्रेजेंस ऑफ माइक्रो ऑर्गेनिज्म इन वाटर, लाइक हाउ मच बैक्टीरिया इज प्रेजेंट, virus is present, or we can say if it is not, then protozoa is present or not. तो अगर इसका क्यों जरूरत है, अगर आप देखना चाहते हो कि biological water quality parameter is the main parameter for the drinking water, for the potability of water. पोर्टेबिलिटी का मतलब क्या है? मतलब अगर आप सोचो कि एक पानी का सैंपल आपको दिया गया, और पानी का सैंपल में कैल्शियम कितना है, मैग्नीशियम कितना है, आयरन कितना है, डिजोल्व ऑक्सीजन है कि नहीं, ये सारी चीज बहुत दूर का सोच है. पहला चीज तो है कि आप देखने का कोशिश करते हो कि कुछ मतलब खाली आंखों से या बाहर से कुछ समझ में आ रहा है कि नहीं, और या तो दूसरा चीज काम करता है कि माइक्रो ऑर्गेनिज्म है कि नहीं. because there are two type of disease generally observed. One is vector borne disease, another one is this one is water borne disease. वाटर बॉर्न डिजीज मतलब पानी के वजह से पानी में रहते हुए कुछ कुछ माइक्रो ऑर्गेनिजम्स हैं, दोज हु आर एक्चुअली पैथोजेनिक इन नेचर. पैथोजेनिक का मतलब है दोज माइक्रो ऑर्गेनिज्म कैन स्प्रेड द डिजीजेस. एज एग्जांपल, jaundice is caused by a virus infectious hepatitis present in water, drinking water मतलब water. नाउ द पॉइंट इज इसके सिवाय और भी बहुत कुछ हो सकते हैं, जैसे पोलियो, बाई पोलियोमाइलिटिस, एमीबायोसिस और कॉलेरा, एंड सम डिजीज आर वेक्टर बॉर्न मतलब जब कभी कभार कुछ एनिमल्स की वजह से वो फैलता है, जैसे आप बोल सकते हैं प्लेग, हैंटा वायरस, निपा वायरस. Those are the vector-borne disease, and still it is the point of concern that how coronavirus has spread. Our whole world has changed, and it's still changing, and we don't know what extent that change will occur. Our life has changed a lot due to this particular virus. Then I should not utter that it has spread by bat or it has spread by this, because it's still under prediction process. So, but again, once again, we can say that yeah, COVID-19, the disease caused by this coronavirus, will be a vector-borne disease. Till date, that is the perception here. Anyways, what is actually the process? What is we are actually going for in the biological water quality parameter, that we want to check the water, that whether the water is fit for drinking, safe for drinking in terms of biological process. Remember, this is the most important parameter in terms of potability of water. बल्क प्रोसेस के लिए बात नहीं कर रहा हूँ, छोटा मोटा प्रोसेस के लिए अगर आपको बोला गया है एकदम साफ सुथरा पानी, बाहर से कुछ भी दिख रहा है कि एकदम एकदम साफ है, लेकिन वहां पे बोला गया है कि उसमें कुछ पर्टिकुलर डिजीज का या कोई कोई डिजीज का भी छोड़ दीजिए, अगर बोला गया कि वहां पे माइक्रो ऑर्गेनिज्म है, तब भी आप नहीं पीने वाले हो, क्योंकि इट इज देयर कि भैया माइक्रो ऑर्गेनिज्म है, मतलब कौन सा माइक्रो ऑर्गेनिज्म है वो पता नहीं, लेकिन कुछ अगर कुछ है, that means quite obviously we will go for this, quite obviously in that process some problem will be there in the water, and the water will cause something. तो ऐसा ही है कहानी कि एक वाटर सैंपल के लिए आप कितने माइक्रो ऑर्गेनिज्म और बैक्टीरिया के लिए टेस्ट कर सकते हैं, क्योंकि बहुत सारे माइक्रो ऑर्गेनिज्म है, बैक्टीरिया है, वायरस है, जो जिसके वजह से कुछ ना कुछ दिक्कतें हो सकते हैं। तो सोचिए कि आपके पानी में आप कंसर्न हो कि भैया जॉन्डिस ना हो जाए, कॉमन डिजीज है, आप कंसर्न हो कि पोलियो ना हो जाए, आप कंसर्न हो कि क्या बोलते हैं कॉलेरा ना हो जाए, उसके बजाय भी हर जगह पे तो डेट्रीमेंटल नहीं होता है, लेकिन दिक्कतें करते ही रहते हैं। जैसे हो सके कि कॉलेरा ना हो, जॉन्डिस ना हो, पोलियो ना हो, लेकिन एमीबायोसिस इंटेस्टाइनल डिसऑर्डर के लिए वायरस है या प्रोटोजोआ है, और टाइफॉइड के लिए है आपका माइक्रो ऑर्गेनिज्म। So it's not possible to qualify the water whether it is directly, that whether it is free from all type of microorganism। मतलब ये ऐसा अगर ऐसा है कि आपको बोला गया है कि पानी का सैंपल देते हुए कि बोल दो कि इस पानी में, इट्स पॉसिबल, ये बोल दो कि इस पानी में सारे माइक्रो ऑर्गेनिज्म जो जो फैलाता है आपका डिजीज, उसका तो बड़ा सा लिस्ट होगा, 250-300, उससे भी ज्यादा भी हो सकता है, तो मतलब 1000 दो के ऊपर होगा। तो एंड समटाइम्स इट मे हैपन कि न्यू वायरसेस यू विल फाउंड, तो वो है कि नहीं। तो ये सारे टेस्ट करने में तो आपका तो साल भर लग जाएगा, तो भैया तब आप बोल पाओगे कि ये पर्टिकुलर वाटर सैंपल पीने लायक है कि नहीं। तो इतना तो लेंथी प्रोसेस में हम लोग नहीं घुसेंगे। वी नीड टू टेल इट वेरी क्विकली वेदर द वाटर इज फिट फॉर ड्रिंकिंग और नॉट, or it is devoid of microorganism or not. In that case, what we'll do, what we'll do, we will go for, see here it is written, it is the most important parameter. Microorganism causes diseases, these are called as pathogens, and biological water parameter is estimated on the basis of the presence of E. coli or Escherichia coli. Actually ये सारे चीज को हम लोग नजरअंदाज करेंगे कि इतना ज्यादा देखेंगे नहीं, देखेंगे कोई एक को सोचेंगे, एक को टारगेट करेंगे और पकड़ लेंगे कि वो एक है तो सब है, या तो वो एक नहीं है तो कोई नहीं है। ओके, तो ऐसा है कि वो एक नहीं है तो कोई नहीं है, मतलब और ये एक है तो सब है, ये कहानी में सबसे ज्यादा ये होता है कि किसको चूज करेंगे, किसको टारगेट करेंगे। तो हम लोग टारगेट किए हैं बायोलॉजिकल वाटर क्वालिटी पैरामीटर के एक दोस्त वाला माइक्रो ऑर्गेनिज्म। हर माइक्रो ऑर्गेनिज्म हमारा दुश्मन नहीं होते हैं, all are not enemies, some microorganisms are friend also, and as example that particular microorganism E. coli or Escherichia coli, previously also called as Bacillus coli or B. coli, ये जो माइक्रो ऑर्गेनिज्म है ये हमारे हर इंसान के, सिर्फ इंसान नहीं, हर वार्म ब्लडेड एनिमल इंटेस्टाइन, वार्म ब्लडेड एनिमल इंटेस्टाइन में मतलब it can be human being, it can be a cat, it can be a dog, it can be a cow, buffalo, anything जिसका खून गर्म होते हैं, वार्म ब्लडेड मतलब स्नेक का नहीं रहेगा, snake blood is cold, so warm blooded animal intestine, eventually that warm blooded animal intestine में E. coli रहते हैं। what they do, they used to stay in our intestine and they help us to digest the food, उसके बदले में थोड़ा बहुत खाना मिल जाता है, उनको रहने का जगह मिल जाता है, वो खुशी खुशी रहते हैं। हमारे इंसान जैसे नहीं है कि भैया रहना खाना तो छोड़िए, पैसा पहले, उनको उतना कुछ तो नहीं चाहिए होता है। तो इकोलाई को टारगेट किया है, क्यों? क्योंकि पहला तो बात है कि इकोलाई अगर ऐसे है कि हमारे मतलब इंटेस्टाइन में रहता है, तो इकोलाई पानी में अगर मिलेगा तो बोल सकते हैं कि ये एनिमल एक्सक्रीटा से पानी पॉल्यूटेड है। अगर एनिमल एक्सक्रीटा से पानी पॉल्यूटेड है, वी शुड नॉट ड्रिंक दैट वाटर फर्स्ट ऑफ ऑल। एंड सेकेंडली एक पॉइंट है कि इकोलाई ऐसा है कि अगर इकोलाई है, इकोलाई जैसा दोस्त इस सैंपल में है, तो दुश्मन कोई भी रह सकता है। वाटर इज फिट नॉट फिट फॉर ड्रिंकिंग। एंड थर्ड एंड मेजर पॉइंट इज, अगर आप जो पानी का टेस्ट करेगा डिफरेंट माइक्रो ऑर्गेनिज्म के लिए, वो चीज उसके लिए भी खतरनाक है। any touch or anything can happen, and it can cause that the pathogen has entered the body of that particular person and he or she is getting infected by that pathogen. इकोलाई टेस्ट करने में वो मतलब नेगेटिविटी है ही नहीं, क्योंकि इकोलाई इज फ्रेंड टू माय आवर्स और फ्रेंड टू आवर बॉडी इटसेल्फ. There is a definition of E. coli present. E. coli is coliforming, facultative, non-pathogenic, gram-negative, round-shaped bacteria present in. E. coli is coliforming, facultative, non-pathogenic, gram-negative, round-shaped bacteria present in every warm-blooded animal intestine. Presence of E. coli is actually indicating that the water may get infected by microorganisms. That is why E. coli is also called as indicator microorganism. Okay, so the presence of E. coli as the presence of E. coli is indicating whether other microorganisms are present or not. That's why E. coli is also called as indicator microorganism. Indicator microorganism. So lot many properties are provided here. Lot many properties are provided here. Now see, coliforming, facultative, non-pathogenic, gram-negative, and round-shaped and bacteria. So lot many properties are present. So let's see. First of all is coliforming. What is coliforming? The term coliforming has came from colony formation. कॉलोनी फॉर्मेशन का मतलब क्या होता है? कॉलोनी मतलब आप देखे हैं, जैसे जो लोग अभी पटना से जुड़े हुए हैं हमारे साथ, तो वहां पे कंकड़बाग बोल के एक जगह है, तो वहां पे बोलता है कि एशिया का सबसे बड़ा कॉलोनी है। तो ऐसे कॉलोनी बहुत सारे हैं। कॉलोनी का मतलब क्या होता है कि एक छोटे जगह पे बहुत लोग एक साथ रहते हैं, and generally it is for the low income group or the for the bottom part of the our economic society, and they used to stay with each other, stay by helping each other. ठीक है, एक सिनर्जिस्टिक इफेक्ट है वहां पे, सिम्बायोटिक इफेक्ट है, जहाँ पे एक दूसरे को हेल्प करते रहते हैं, मतलब ऐसे अलग अलग बात नहीं है. दैट इज कॉल्ड एज कॉलोनी. तो दैट इज आइडियल डेफिनेशन ऑफ कॉलोनी. ऐसा नहीं है कि हर जगह पे ऐसा ही होता है. तो कॉलोनी फॉर्मेशन मतलब ये इकोलाई है, स्टे इन अ ग्रुप. छोटे छोटे माइक्रो ऑर्गेनिज्म है, अलग अलग रहेंगे तो उसको ट्रेस करना भी मुश्किल होता है, सिंगल सिंगल रहेंगे तो नॉर्मली इकोलाई एज दे स्टे इन अ ग्रुप, तो क्या होता है कि एक साथ बहुत सारे इकोलाई रहते हैं. इसके वजह से द ट्रेसिंग प्रोसेस ऑफ इकोलाई, उसको ट्रेस करना आसान हो जाता है. बिकॉज as lot many small microorganisms are staying together, then identifying them is much more easier because they can appear as a single mass, bigger size mass. That's why. Then next property has coming as facultative. Facultative. On the basis of oxygen requirement, microorganism is of three types. On the basis of oxygen requirement, microorganism will be of three types: aerobic, anaerobic and facultative. Aerobic का मतलब है ऑक्सीजन इज मस्ट, ऑक्सीजन रिक्वायरमेंट इज मस्ट. anaerobic का मतलब है ऑक्सीजन एब्सेंस इज मस्ट, ऑक्सीजन एब्सेंस इज मस्ट. And facultative means doesn't matter. मतलब doesn't matter मतलब that particular microorganism can uh, sustain in aerobic condition as well as in anaerobic condition. So oxygen requirement is must for aerobic. Anaerobic means oxygen absence is must. Facultative means doesn't matter. तो E. coli facultative है क्या मतलब है? E. coli can sustain both the aerobic condition as well as the anaerobic condition. E. coli can sustain both the aerobic condition as well as the anaerobic condition. तो एरोबिक और एनारोबिक कंडीशन मतलब देखिए, इकोलाई मैं पहले ही बोला हूं कि दे प्रेजेंट इन एवरी वार्म ब्लडेड एनिमल इंटेस्टाइन. तो वार्म ब्लडेड एनिमल इंटेस्टाइन में अगर वो रह सकते हैं, दैट मींस दे आर स्टेइंग इन अ एनारोबिक कंडीशन बिकॉज इकोलाई generally they stay in anaerobic warm animal intestine is anaerobic condition. The oxygen will not enter, will to enter. Facultative or E. coli can stay in water also. So that is they are getting exposure to atmosphere. That is aerobic. So eventually they can stay in aerobic and anaerobic condition both. That's why they are facultative in nature. Non-pathogenic. Pathogenic का मतलब होता है disease forming. Non-pathogenic का मतलब होता है non-disease forming. Okay. Gram negative. Actually, there is a solution called as Gram solution invented by biologist Christian Gram, and the whole microorganism world has classified on the basis of that half of them the cell wall are absorbing Gram solution, they are Gram positive microorganism. Some of them are not absorbing the Gram solution, they are called as Gram negative microorganism. E. coli is Gram negative, that means E. coli cell wall don't absorb the Gram solution. Now we are coming to the major segment of this part, that is test for E. coli. That is test for E. coli. Now E. coli test will be of two types. One is qualitative test, another one is quantitative test. It is of two types, qualitative test or quantitative test. In qualitative test, the answer will be yes or no, whether E. coli is present, yes or no. In quantitative test, the answer will be how much. If E. coli is present, then how much E. coli is present. So in qualitative test, the quality of water will be estimated that E. coli is present. Yes. E. coli is present. No. In quantitative test, we are going to find out the number, how much E. coli is present in the water. Number of E. coli. Qualitative test is performed or is done by plate count method. This qualitative test is done by plate count method. What is that plate count method? A rectangular shaped plate will be taken. A rectangular shaped plate will be taken, and which is called as petri dish. A rectangular shaped plate will be taken, which is called as petri dish. And that rectangular shaped plate, the inner layer of that plate will be coated by a food solution called as agar solution. The inner layer of petri dish will be coated with a solution called as agar solution, food to microorganism. Mu means this microorganism. In short, I am writing. Okay, don't get confused with. So first you are taking a rectangular shaped plate, petri dish, and then uh, we are putting the inner layer, coating the inner layer by uh, by a food to the microorganism that is called as agar solution. Then after that, we are putting the water sample which we want to test, and in the water sample, then we are keeping the whole system in incubation. Incubation matlab non-disturbed condition or undisturbed condition. In incubation for 24 hours at 30 degrees centigrade. We are keeping the whole water sample in incubation for 24 hours at 30 डिग्री सेंटीग्रेड. तो हम कर क्या रहे हैं? एक्चुअली हम एक आधार लिए हैं जगह, वहां पे माइक्रो ऑर्गेनिज्म के लिए फूड दिए हैं, पानी है, और उस सिस्टम को हम लोग 24 घंटे के लिए 30 डिग्री सेंटीग्रेड टेम्परेचर में छोड़ दे रहे हैं. So what we are actually doing? We are actually supporting the growth of microorganism. How? First, see, we are putting food, water is there. If the water sample contains microorganism or E. coli, then as they are getting food, water, undisturbed condition and time 24 hours and a temperature 30 degrees centigrade, which is favorable for their growth, then they will happy with this, they will be happy with this condition, they will multiply with numbers. So after 24 hours, the different segment of this water will be taken and tested under a microscope. The special microscope will be colony counter microscope. Colony counter microscope. That is colony counter microscope. And in that colony counter microscope, if you see, if you observe any kind of two black, purple, brown dot, any color, blue, black, purple, or brown dot, then your answer is yes, E. coli present in the system. If no dots are present, then your answer is no, E. coli is not present in the system. Blue, black, purple, brown dot is observed, yes, E. coli is present. No dots are observed, E. coli is not present. That is qualitative test. Generally, the quantitative test of E. coli, try to understand this quantitative test in details, because you will get the question from the last segment of this test. But if you don't understand the process, getting the or solving the question will not be simple or easy. In quantitative test, it is done by multiple tube fermentation test. It is done by multiple tube fermentation test. What is multiple tube? Why it is called as multiple tube fermentation test? I will tell you. To perform this quantitative test, two steps are required. And the first step is called as presumptive test, and the second step is called as confirmatory step. Two steps are required. First step is called as presumptive test. Second step is called as confirmatory test. So in presumptive test, in the first step, first we need to identify the water sample of volume in the power of 10 and the sequence of 3. देखिए गौर तरीके से समझिए, टेस्ट ट्यूब लिया जाएगा, टेस्ट होगा, टेस्ट ट्यूब का वॉल्यूम है मैक्सिमम 100 ml, ठीक है। तो कहानी है कि वॉल्यूम ऑफ वाटर सैंपल, जो वेस्ट वाटर सैंपल है, वो चुनने के टाइम पे आपको गौर तरीके से देखना पड़ेगा कि व्हाट वॉल्यूम यू आर चूजिंग। एब्रप्टली यू कैन चूज एनी वॉल्यूम। इट कैन बी 100 ml, सबसे ज्यादा 100 ml ही हो सकते हैं, तो इसीलिए 100 ml which is 10 square. It can be 10 which is 10 to the power 1. It can be 1, it is 10 to the power 0. It can be 0.1, 10 to the power minus 1. 0.01, 10 to the power minus 2. 0.001 to 0.001. 0.001 तक ही जाएंगे, उससे नीचे मतलब बहुत कम वॉल्यूम हो जाते हैं, दैट वी आर नॉट कंसर्न। So you can't take 50 ml, 60 ml, 70 ml, 20 ml, 30 ml, 25 ml, 45 ml, 47 ml. It's not possible. You have to take the volume in the power of 10 and in a sequence of 3. That is very important. A sequence of 3. Sequence क्या है? 100, 10, 1, 0.1, 0.01, मतलब ये आ रहा है, ठीक है। तो सीक्वेंस चाहिए 10, 1, 0.1, 0.01, ऐसा है सीक्वेंस। तो ये आपको जो वॉल्यूम चूज करना है, वो वॉल्यूम में आपका जो है वो मिनिमम ऑफ 3 सीक्वेंस में हो सकता है, उससे ज्यादा भी हो सकता है, लेकिन मिनिमम 3। मतलब आप एब्रप्टली ऐसे नहीं ले सकते हैं, आपको लेना है, अगर आप 100 को चुन रहे हैं तो 100, 10, 1 विल बी द सीक्वेंस, 10, 1.1 will be the sequence, 1.1.01 can be a sequence, 0.1, 0.01, 0.001 can be a sequence, 0.01, 0.001, 0.0001 can be a sequence, or 110, 1.1 can be a sequence, because it's a continuously, it's a sequence of 4, but minimum 3 का sequence लेना है। और आप ऐसे नहीं ले सकते हैं कि 100, 1.01, नहीं हो पाएगा, और 10, 0.1, 0.01, that is also not possible. You have to take the thing volume in a sequence of 3 minimum, उससे ज्यादा भी आप ले सकते हो, ओके। सच सोचिए कि हम लोग एग्जाम्पल ले चुके हैं, यहाँ पे लिखा हुआ है एग्जाम्पल, choosing a sequence of 10, 1.1. We are choosing a sequence of 10, 1.1. Okay. Now, for each and every volume, we need to take 5 test tubes. मतलब ऐसे टेस्ट ट्यूब लेंगे और टेस्ट ट्यूब में 10 ml का वाटर पानी लेंगे, वेस्ट वाटर, सॉरी वाटर सैंपल हियर, ऐसे 5 टेस्ट ट्यूब होगा, 1 ml का 5, 0.1 का 5, जैसे 10, 1.1 हम लोग चूज किए हैं, इसीलिए मैं बता रहा हूँ। तो अगर आप और एक सैंपल और एक सीक्वेंस में लेते 10, 1.1, 0.01, तो उसके लिए भी 5। तो भैया क्या हो रहा है, मिनिमम 15 test tubes are required to conduct this test. Minimum 15 test tubes are required to conduct this test. And that's why it is called as multiple tube test. That's why it is called as multiple tube test. Why it is called as this fermentation test, I will tell you later. But minimum 15 test tubes are required to conduct this test. That is why it is called as multiple tube test. Okay, that is step. Is that clear? Now, तो यहाँ पे 10 ml लिए हैं, 100 ml का टेस्ट ट्यूब है, बाकी 90 ml क्या करेंगे, हर चीज में फिल ऑल द टेस्ट ट्यूब्स विद डिस्टिल वाटर। तो यहाँ पे 1 ml मतलब 99 ml will put distilled water, 0.1 ml sample मतलब 99.9 ml will put distilled. Clear? Now, after that, each and every test tube, we are going to add 4 to 5 drops of fructose solution is mixed in each tube, and the mouth part will be closed by cork and Vaseline. हर सैंपल में, हर टेस्ट ट्यूब में 4 से 5 ड्रॉप, 4 to 5 drops of fructose solution will be added, and after that the mouth part of the test tube will be uh, the mouth part of the test tube will be closed by cork and Vaseline. The mouth part of the test tube will be closed by cork and Vaseline. Here. Finally, what will happen? We will keep all the test tubes. We will keep all the test tubes in incubation for 24 hours at 25 to 30 degrees centigrade. Finally, we will keep all the test tubes in incubation for 24 hours at 25 to 30 degrees centigrade. 25 to 30 degree centigrade. What will happen? E. coli will ferment the fructose solution and produce कार्बन डाइऑक्साइड गैस. इकोलाई का काम है कि फ्रुक्टोज सॉल्यूशन को फर्मेंट करके कार्बन डाइऑक्साइड गैस प्रोड्यूस करेगा. मतलब, और विच विल क्रिएट, अब वो गैस कहाँ जाएगा? अब माउथ पार्ट तो बंद कर चुके हो, ऑब्वियसली देयर विल बी gas bubbles inside the system. So जिस टेस्ट ट्यूब में इकोलाई है, उस टेस्ट ट्यूब में 24 घंटे बाद आपको गैस बबल्स दिखेगा. These gas bubbles actually indicate the presence of E. coli. The gas bubbles will indicate the presence of E. coli. So after 24 hours, in the test tubes where we are going to observe gas bubbles, carbon dioxide gas bubbles, or rather than gas bubbles, we are not, then that there E. coli is present, else E. coli is absent in the test tube. Clear? So in multiple tubes, we are actually enhancing the fermentation, and we are finding out the process whether E. coli is present or not. Is called as, that's what is called as multiple tube fermentation test. That's what is called as multiple tube fermentation test. Now, the final step, a table will be generated. A table, that is मतलब a result का representation का table है, to generated to showcase the result. जैसे sample total 10 1.1 ले चुके हैं, 5 5 5 का टोटल है. पॉजिटिव सोचिए, मतलब 5 में 10 ml जितने जहाँ पे लिए हैं, 5 में से 4 में आपका गैस बबल्स मिला है, 1 में नहीं मिला है, जैसे पॉजिटिव 4 1 3 2. This 4 3 2 is called as positive result combination. This 4 3 2 is called as positive result combination. This 4 3 2 is called as positive result combination. ये जो स्टेप 1 to स्टेप 6 है, पहले स्टेप से स्टेप 1 to स्टेप 6 is called as prism tip test. Is called as prism tip test. Now we are going for the next step, stage 2, which is called as confirmatory stage. We are going for the next stage, which is called as confirmatory stage. Now what will happen in confirmatory stage? So in confirmatory stage, we are not going to do anything biologically or anything biological experiment or in the anything laboratory experiment here. What we will do, in confirmatory stage, we will compare our result with the we will compare our result with the ideal result. अब क्वेश्चन है कि आइडियल रिजल्ट कौन देगा? Ideal result actually a table already it's being generated. You will get the table also in exam hall. That is टेबल मतलब ऐसे अलग से कोई टेबल लेवल नहीं देगा, वो क्वेश्चन के साथ ही रहेगा. अब समझ में आ जाएगा जब क्वेश्चन सॉल्व करेंगे देखेंगे. That is produced by WHO previously. So there what will happen, 10.1.1 के लिए सारे परम्यूटेशन कॉम्बिनेशन का पॉजिटिव रिजल्ट या परम्यूटेशन कॉम्बिनेशन का वैल्यू उसके कॉरस्पॉन्डिंग वैल्यू है. That is a number. What is the highest possible permutation possible thing? Highest possible thing there where you will get proper thing? That is 555 there, and lowest possible is 000. So in this table you need to find out where is your positive combination value. Here is 432. Here is 432. Correct. So to find out, suppose the value, the corresponding value is 100. So your final answer will be represented by most probable number MPN. आप कर क्या रहे हो? आप बोल रहे हो कि भैया मेरा रिजल्ट है 432 का कॉम्बिनेशन. आइडियली उसके साथ 100 नंबर जुड़े हुए हैं, मतलब 432 कॉम्बिनेशन में 100 माइक्रोऑर्गेनिज्म रह सकते हैं. तो मोस्ट प्रोबेबली ये पॉसिबल नहीं है कि एक एक को गिनना. आप बोल रहे हो कि मोस्ट प्रोबेबली आपका जो नंबर है वो है 100 नंबर पर 100 ml. Understood? So as you were representing the value as the most probable number, most probably this will be the value. आपका वैल्यू उससे कम भी हो सकता है, उससे ज्यादा भी हो सकता है, लेकिन ideally it is the value. That's why you are telling that probably it will be the value, that 100 number per 100 ml in this case. Understood? And your drinking water standard, the drinking water standard where MPN will be less than equals to 1 number per 100 ml. MPN should be less than equals to 1 number per 100 ml. That will be your drinking water standard. That will be your drinking water standard. Now, we need to understand two special cases. Two special cases we need to understand. So first is when test volume is not matching with the table volume. अगर टेस्ट वॉल्यूम टेबल वॉल्यूम के साथ मैच नहीं कर रहा है, then what you will do? Suppose you have done with that 10.1.1, गलती से आपके पास जो टेबल आया हुआ है that is for 110.1 के लिए, क्या करोगे? कुछ नहीं, जैसे आप कर रहे थे प्रीवियसली 10.1.1 का पॉजिटिव रिजल्ट कॉम्बिनेशन उठा लीजिए, that is 432. 432 को बैठाइए आपका 110.1 वाला टेबल में, जो टेबल दिया हुआ है उसमें देखते हुए देखिए कि उसका कॉरस्पॉन्डिंग नंबर क्या है. उसका कॉरस्पॉन्डिंग नंबर जो है उसको उठाइए. नाउ योर एमपीएन वैल्यू will be the corresponding value into minimum volume of the ideal table by minimum volume of test. MPN is equals to corresponding value into minimum volume of ideal table by minimum volume of test. but MPN is equals to 10 corresponding value into minimum volume of the ideal value is 1. That is the minimum value of the ideal table. And what is the minimum volume of test is 0.1. So 1 by 0.1, once again it will be 100 number per 100. Here. Now, going for special case 2. We are going for special case 2. Suppose a person, a student, very serious, like you, has done a test by taking 20 test tubes, means a sequence of 4. 10, 1.1.01 bar sequence. Ten, 1.1 bar sequence and 0.01. So taken 555 for 4, 3, 2, 1 samples are taken. That is the positive result combination. This one is a positive result combination. And quite obviously, this is negative, which is not the point of concern. Here, the sample volume. Okay. So, obviously, ideal table will be provided with a sequence of 3 only. So, what to do? या तो आप लीजिए 10 1.1, इसके लिए आपका आएगा 432 कॉम्बिनेशन, या तो लीजिए 1.1.01, जिसके लिए आपको आएगा 321 कॉम्बिनेशन, 432 और 321. Now, what we have to choose? हमेशा याद रखिएगा, हमारे सिचुएशन में मिनिमम वॉल्यूम इज द की. Minimum volume is key. Why? Because if you because if suppose there is the minimum volume is 0.01, means you are choosing 1.1.01. जिस सीक्वेंस में आपका मिनिमम वॉल्यूम रहेगा उसी सीक्वेंस को आपको चुनना पड़ेगा. तो क्या है मिनिमम वॉल्यूम इज की, मैंने लिखा हूं. क्यों लिखा हूं? क्योंकि it is assumed that if it is true also if 0.01 ml of water sample contains E. coli, the 10 ml sample will obviously contain E. coli. Is 3 to 1 that you need to put. Now that you are putting here corresponding value you are choosing, but what is happening now? But what is happening now? When you are choosing the corresponding value for 1.1.01, but your table is now 10 1.1, so your second case is converted into first special case now, where your test volume, because your test volume means here now this 10 you have to forget. Now your table is for 1.1.0, where test volume is not matching with standard table volume. Again, you have to go for MPN will be 5 into minimum volume of ideal table, that is 0.1, and minimum volume of the test, that is 0.01, and it will be the final answer. Okay. That is what we have covered. Just I'm going for the first ones. Biological water quality parameter. We are going for the test for E. coli. What is E. coli is described here. Then the properties are described here. What is the quantitative test? Confirmatory stage of the quantitative test. Now, finally, there is a list of the disease, organism, and category. Cholera, Vibrio cholerae, category bacteria, typhoid, Salmonella typhi, just it's not the all, just a normal one. Bacteria, paratyphoid, Salmonella, paratyphi, bacteria, dysentery, Shigella dysentery by protozoa, intestinal disorder by Entamoeba histolytica, polio is done by poliomyelitis virus, jaundice is infectious hepatitis by virus. These are a small list, very small list of waterborne disease, organism, and their category. That is the end of biological water quality parameter. That is the end of biological water quality parameter. Now we will start discussing entering, that is the main topic for today's, that is treatment. Will start the treatment of water. Quality checking हो चुके हैं. Now we have to treat the water, and the first thing what we will go for is plain sedimentation process. Before going to the plain sedimentation process, we need to discuss the prelude of this chapter. Just a minute. What is the object of that water treatment process? हमको देखना है कि water treatment process है क्या, और क्या क्या हम लोग अप्लाई कर सकते हैं, क्या चीज हम लोग अप्लाई कर सकते हैं. Something present in water needs to get removed to increase the quality of water. जो भी है वाटर का जो एक्चुअली रहना नहीं चाहिए और जो एक्चुअली ह्यूमन हेल्थ के लिए सही नहीं है, जो इंडस्ट्रियल प्रोसेस के लिए सही नहीं है, जो आपका आइडियल वैल्यू से जिसका कंसंट्रेशन ज्यादा है, we need to remove it. And to removal techniques, treatment techniques will be of two type. Either it is unit operation or it is unit process. इसको कहते हैं unit operation. When the treatment is done by physical process, it is called as unit operation. The treatment is done by physical process, मतलब बाहर से कोई chemical use नहीं हो रहा है, कुछ भी नहीं हो रहा है, just it is done by applying certain physical forces. It is done by applying certain physical forces, like it is done by applying gravity force, pressure force, like this. Another one is unit process, where the treatment is done by applying certain chemicals from outside. We will see different treatment techniques. We will identify which are unit operation, which are unit process. तो हम लोग treatment में घुस चुके हैं. That is a major segment. Lot many things are there. Theoretical concept is important as well as the mathematical also. So something present in water needs to get removed to increase the quality of water. The treatment techniques will be of two types: unit operation and unit process. Now, before going to the details, हम details में जाने से पहले कुछ चीजें हमको याद रखना पड़ेगा. That we are more concerned in the domestic water supply part. We are more concerned about the quantity than the quality of. अगर हम क्वालिटी को कुछ जगह पे बहुत नजरअंदाज करेंगे, क्वालिटी को कंप्रोमाइज करेंगे टू फॉर अ बेटर quantity treatment, or we can say that we will that just sometimes skip the quality parameter to get a good quantity water. Good means हमको volume ज्यादा जरूरत है. And whatever we are going to talk about, please keep in mind, whatever we are going to talk about, whatever we are going to discuss about, that is the most basic and ideal treatment scenario and phenomena. That is the most basic ideal treatment sequence and phenomena. It is not it is the most basic ideal treatment scenario and phenomena. वास्तव में बहुत जगह पे it will be changed, it can be modified, it can be altered depending on the source water quality. It is the most basic. Once again, I'm telling you, it is the most basic. Whatever we are going to discuss, most basic and ideal approach. Okay. The particles will be of generally two types of impurities will be considered here. Two types of impurities will be considered. One is particle, another one is microorganism. And we know that particles will be of three types: suspended particle, colloidal particle, and dissolved solid. Suspended particle size ranges in between 10 to the power minus 1 to minus 3 millimeter in diameter, whereas the colloidal particle size ranges in between 10 to the power minus 3 to minus 5 mm in diameter. That is also it's discussed. And dissolved solid, the particle size ranges in between 10 to the minus 5 to 10 to the minus 8 millimeter in diameter. That is the scenario. Okay. Suspended particle, colloidal particle, and for dissolved solids. So, if you see surface water treatment scheme, that again I am telling you, repeatedly I am telling you, हम लोग जो देख रहे हैं, that is the most basic and ideal treatment sequence. वास्तव में in real cases, lot many changes, addition, alteration, modification will be there, and all will depends on the raw water quality parameter. This raw water will undergo current treatment scheme. They are number one, plain sedimentation, number two, coagulation and flocculation, Now, then it will go to the filtration, then it will go to disinfection, and finally it will get supplied. So the first process will be plain sedimentation, first thing. Then it will go to the coagulation flocculation, then filtration, then disinfection, that will be supplied. So see, first one, plain sedimentation is actually used to remove the suspended particle. Second one, coagulation and flocculation will be used to remove the colloidal particle. Third one, this filtration will be used to remove the dissolved solids, and finally disinfection will be used to remove microorganism. So as I have told you previously that we will only consider particle and microorganism as the impurities. That's why all the particles and microorganisms are dealt, all type of particles and microorganisms are dealt here with this scheme, treatment scheme. Now that is for the surface water. That is for surface water. Now we know there is another source of water, that is groundwater. Groundwater कैसे form होते हैं? Due to the percolation of surface runoff or surface water sometimes to the soil pores. है कि हाँ कि नहीं? तो भैया ये ग्राउंड वाटर इज डिवॉइड ऑफ वेरी गुड क्वालिटी वाटर, डिवॉइड ऑफ suspended and colloidal particle. Groundwater generally devoid of suspended and colloidal particle. But it is lagging in dissolved oxygen and hardness is much higher. यहाँ पे डिजोल्व ऑक्सीजन नहीं रहते हैं. डिजोल्व ऑक्सीजन जब पढ़े थे हम लोग देखे हैं, हम बोले भी हैं ये सब सारे बातें. तो ऐसा है कि सस्पेंडेड एंड कॉलोइडल पार्टिकल अगर नहीं है तो पहला दो जो चीज है सेडिमेंटेशन एंड कोआगुलेशन फ्लॉकुलेशन, इसको देने का कोई जरूरत भी नहीं है ग्राउंड वाटर के ट्रीटमेंट स्कीम में, और नहीं भी दिया जाता है. Groundwater treatment scheme, it will different. Aeration technique will be the first, then there will be water softening, then there will be filtration, then there will be disinfection, and that will be supplied. Then finally it will get supplied. First will be aeration technique. Aeration technique is the thing which will actually aerating the water. That means it's actually putting extra oxygen to water. That is to the target for this target of oxygen, dissolve oxygen part. Water softening is actually the removal of hardness. So see, aeration will put extra oxygen and remove carbon dioxide and H2S gas. Removal of hardness will be done by water softening process. Filtration will do for dissolved solid, and disinfection microorganism. These 3 and 4 is already discussed. So eventually that is the treatment scheme of surface water, and this is the treatment scheme of groundwater. Surface water and groundwater, these are the treatment scheme. Clear? So in our treatment of water chapter, first we will go for plain sedimentation. So these are the different segments. Different segments we will discuss. First we will discuss plain sedimentation. Second we will discuss coagulation flocculation. Third we will discuss filtration. In the fourth segment, we will discuss disinfection. And finally, another chapter will be there. It will be called as miscellaneous treatment process, where we will briefly discuss aeration technique and water softening technique and some other techniques also briefly. So there are five segments of water quality, that is for this water treatment process. First one is plain sedimentation. Second technique will be coagulation flocculation. Third subchapter will be filtration. Fourth one is disinfection, and fifth one will be the miscellaneous treatment, where groundwater treatment process will be observed or will be discussed briefly. Okay. Now we are entering to the first segment of this chapter of this treatment process is plain sedimentation process. We are entering to the plain sedimentation process. Plain sedimentation is the process of dealing with suspended solid that I have already told you. And generally, suspended solid size ranges in between 10 to the minus 1 to minus 3 millimeter in diameter. Yeah, I have plain sedimentation. Just try to see. Suppose this is a bottle of water. It's not a suppose, it's obviously a bottle of water, half filled. You put some suspended particles, put some mud particles here and mix it well. Then keep this bottle in stabilized condition for sometimes half an hour, 1 hour, 2 hour, whatever it may be. What you will observe? You'll observe that after certain amount of time, all these suspended particles, maximum of the suspended particles will get deposited in the bottom layer of that particle. Will get deposited in the bottom layer of this particular bottle, and from top you are going to get the particle free or suspended particle free water. So what is happening here? What is happening here? Particles which are having higher specific gravity than water are getting settled down naturally. No chemicals are getting used from outside. Nothing else is happening. Nothing. So eventually, it is an unit operation, and particles are getting settled down by the force of gravity. It is the first unit operation encountered by water where particles are getting settled down or removed by the force of gravity. And all the particles, those who are having higher specific gravity than water, will get settled down naturally. तो बात यह है कि भैया पार्टिकल अगर नेचुरली सेटल डाउन करते हैं तो उसके लिए अलग से हमको पढ़ने का जरूरत क्या है? क्या ही ऐसा चीज है जो हमको देखना है? Natural sedimentation of particle is opposed by water itself by turbulence and viscosity of water. The natural sedimentation of particle is opposed by turbulence and viscosity of water. Higher velocity, turbulence. हमारा काम क्या है? पानी को लेते हुए पानी का जो टर्बुलेंस है उसको कंट्रोल करते हुए सस्पेंडेड पार्टिकल्स का जो नेचुरल सेडिमेंटेशन प्रोसेस है उसको बढ़वा देना. मतलब what we will do, we will remove the suspended particles from water by controlling. Our job is to control the turbulence, and particle will get settled down naturally itself. Is also called as settling process. sedimentation process or settling process. So removal of suspended particle, sorry, removal of suspended particle from water by controlling the turbulence is called as plane sedimentation or settling process. So what we will do, we are actually controlling the turbulence of water so that the sediment settling process of particle gets enhanced. Generally, in the whole water treatment process, whole world of water treatment, four types of settling process is observed. Four types of settling process is observed. First one is the type 1 settling process, also called as discrete settling. What is that we will discuss. Type 2 settling process, or called as flocculent settling. Type 3 settling process called as hindered settling, and type 4 settling process called as zone settling or compression settling. Among these four type of settling process, the first two settling, type 1 and type 2 settling, we will observe, we will read in details in this domestic water supply engineering process, whereas type 3 and type 4 settling we will see in the wastewater treatment process. So type 1 and type 2 we will see in this domestic water supply engineering process, where type 1 we will see right now, and the type 3 and type 4 settling we will see in wastewater engineering process. Type 1 settling is concerned about the discrete particle. Here it is told discrete settling, because it is concerned about those particles which are called as discrete particle. Discrete particle किसको कहते हैं? आप अपने कॉलेज की लाइफ में अगर याद करोगे, देखोगे कि पहले सोचिए, मतलब वो हमारे टाइम पे होता था, आपके टाइम पे तो खैर बंद ही हो चुका है, लेकिन पहले 2-3 दिन पहले, 2 ढाई महीना ऐसा होता है अभी भी, कि स्टूडेंट्स जो नया फ्रेशर्स जो आते हैं वो एकदम बन ठन के आते हैं भैया, फुल स्लीव शर्ट्स, फॉर्मल्स, इंजीनियरिंग कॉलेजेस लाइक दिस, स्पेशली इफ इट इज प्राइवेट इंजीनियरिंग कॉलेज। तो अभी तो प्राइवेट इंजीनियरिंग कॉलेज में, बहुत सारे प्राइवेट इंजीनियरिंग कॉलेज में ड्रेस कोड भी है, तो खैर दैट इज डिफरेंट। नाउ जैसे ही वो सेमिस्टर बढ़ता जाता है, मतलब फर्स्ट ईयर ऐसा हुआ, सेकेंड ईयर में तो फुल स्लीव शर्ट छोड़ दीजिए, टी शर्ट, थर्ड ईयर में तो वो एक ही टी शर्ट 7 दिन, और फोर्थ ईयर में तो भाई भाई साहब लोग कॉलेज में दिखना ही उनका बंद हो जाता है। एक्चुअली क्या होता है कि इसी लॉट में आप एक दो बंदे को देखोगे तो रहेगा ही रहेगा, पहले साल से लेकर 4 साल तक इसका अप्रोच हमेशा के लिए सेम। वेरी गुड बॉय इमेज, ऑलवेज सिटिंग इन द फ्रंट ऑफ द class, taking all the notes. I'm not telling that they so, and maintaining that attire, almost that attire they are maintaining. These students are called as discrete students, like this discrete particles. The particle which don't change their property, particle which don't change their property with time is called as discrete particle. Property means here mass, shape, size, specific gravity, etc. are point of concern. The particle which don't change their property with time is called as discrete particle. And in plane sedimentation process, settling of discrete particle is concerned, and that is why it is called as discrete settling or type 1 settling or clarification process. तो बहुत सारे नाम है, discrete settling, type 1 settling, or clarification process. So what we are concerned about, we are concerned about the discrete particle, where particle which don't change their property with time is called as discrete particle. In plain sedimentation process, settling of discrete particle is concerned. That is why it is also called as discrete settling or type 1 settling or clarification process. Now, now we need to know what will be the equation for settling velocity, at what velocity particles are going to get settled down. At what velocity particles are going to get settled down. To find out the equation for settling velocity, one spherical particle, that is the ideal one, is concerned. When the particle is in water, so two type of forces will act. This one is gravity force, which will want to take the particle in the downward direction, and another one is buoyancy force. Gravity force क्या है? Force होता है mass into acceleration. Mass is volume into density, so its gravity force will be equals to Vp into rho p into g, which is volume of particle. Vp, rho p is density of particle, and for buoyancy force, Fb will be equals to volume of particle into rho w, density of water, into g. Now, if Fg greater than Fb, agar downward movement is more than upward force, then obviously the particle will come down towards the bottom of the process or flow or tank, whatever it may be. Then particle will settle. But if the upward direction motion, अगर आपका buoyancy force gravity force से ज्यादा होंगे, तो particle will float. So for us, we are actually concerned about the settlement of particle. So for us, we are taking Fg greater than Fp. Downward force is higher than the upward one, then only you can get the settlement. And Fg minus Fp, the net force, is defined as F net, obviously downward direction. F net obviously in downward direction. As the F net is equals to Fg minus Fb, then Fg is equals to Fg, we have written a Vp rho p into G minus Fb is Vp rho w into G. But F net will be equals to Vp into G into rho p minus rho w in downward direction. Now, once motion is initiated, another force will act upon one particle. What force? Any particle, solid particle present in any fluid, if motion is initiated, that force will occur. That is called as drag force. And what is the direction of drag force? The drag force will always will be there, the opposite to the direction of motion. क्योंकि फिक्स डायरेक्शन है नहीं. अगर ये पार्टिकल ऊपर तरफ जाता, फ्लोट होता, तो डायरेक्ट फोर्स विल एक्ट इन डाउनवर्ड डायरेक्शन. If the particle is getting settled down, that means drag force will act in upward direction. And the drag force is expressed as CDAP rho W V square by 2 because CD is equals to drag coefficient and AP is the projected area. Find it. W is density of water and V is the velocity. But why I am putting as suffix S? Because as we are concerned about the velocity for which the particles are getting settled down, that is Vs, that is the settling velocity of particle. So Fd is equal to CdAp rho W Vs square by 2. So at equilibrium condition, your upward direction force will be equals to the downward direction force. So upward direction force is here Fd because it is a drag force and it is drag force and it is acting upwards right now because it is acting opposite to the direction of motion. So this is the upward force and downward force is F net that we have already calculated. So at equilibrium condition, your Fd will be equals to F net. At equilibrium condition, your Fd will be equals to F net. So क्या होना चाहिए? Fd अगर F net के साथ सेम होता है, Fd बैठाइए CdAp rho W V square by 2 is equals to Vp into G rho P minus rho W. What is Vs square? Take the Vs in a left hand side and take everything in right hand side. Vp into G into rho P minus rho W into 2 by CdAp rho W. Now, what is Vp by AP? Vp by AP. Vp is volume of particle and AP is the projected area. Now, as a spherical particle, obviously Vp will be 4 by 3 pi r cube. R is the diameter of the particle. What is AP? If suppose a ball is coming towards you, what you will see? You will see it is as circle. The projected area of the spherical particle will be a circle. So the projected area will be pi r square, which is equals to 4 by 3 into dp by 2. Now it's 2 by 3 dp. That means Vp by AP it can be written as 2 by 3. Okay. So let's go for this. 2 G by CD I am taking along dp by AP, rho P minus rho W by rho W. So V square will be equals to 2 into G by rho CD into what is dp by AP? 2 by 3 dp, 2 by 3 dp into rho P minus rho W, rho P by rho W just taking minus 1. Finally, what we are getting? P square is equals to 4 by 3 G dp by CD into is rho P by rho W is the ratio of density of particle to density of water, which is called as specific gravity. Here I am denoting it as capital G. You can denote it as capital S also according to your wish. But here I will follow the notation as capital G, specific gravity. Capital G, specific gravity, which is rho P by rho W. Okay. So if it is the Vs square, so Vs value under root 4 by 3 GdP into G minus 1 by CD. And this equation is called as the Stokes equation for particle settling velocity. Stokes settling equation for particle settling velocity. Where CD is equals called as coefficient of drag and CD will be equals to 24 by RE for laminar flow, 24 by RE plus 3 by root RE plus 0.34 for transitional flow and 0.4 for turbulent. So CD is equals to 24 by RE is laminar flow for 24 by RE plus 3 point root RE plus 0.34 is for transitional flow, and zero point 0.4 for turbulent. What is RE? No, RE is equal nothing but the Reynolds number, which is nothing but the inertia ratio between inertia force to viscous force. It is the ratio between inertia force to viscous force, and it is nothing but the rho Vd by mu. For our case, for civil engineering case, we need to remember RE for three things. One is for the particle, that is RE. If RE less than 1, it will be laminar. If RE is in between 1 to 10 to the power 4, it will be transitional. If it is more than 10 to the power 4, it will be turbulent. We do know for the pipe flow, that is RE less than 2000 is laminar, 2000 to 4000 is transitional, and greater than 4000 is turbulent. That is one thing. And RE less than 500 will be laminar, 500 to 2000 is transitional, and more than 2000 will be turbulent. That is for open channel flow. These three things for civil engineering process we need to remember for the RE value. For laminar flow. So next go for laminar flow, we need to see the what will be the equation for settling velocity. For laminar flow, CD will be equals to 24 by RE, and RE is rho W Vs dP by mu. We know the uh, Vs squared formation, that is 4 by 3 GdP by CD into G minus 1. If you put in 24 by RE instead of CD, what you are getting, the equation solution is given here, that Vs squared is equal to 4 by 3 GdP 24 by RE. So eventually it's 4 into 6, 6 into 3, 18. 1 by 18 will be there. And RE will go top, so GdP into RE into G minus 1. Now Vs squared will be equals to 1 by 18 GdP. What is RE? Rho W Vs dP by mu into G minus 1. So 1 Vs and this square get cancelled out. So Vs square Vs will be equals to 1 by 18 GdP square, because dP is multiplied with this dP square into G minus 1 by nu. So Vs will be equals to 1 by 18 GdP square into G minus 1 by nu. That is the equation for settling velocity in laminar flow condition. This equation is called as modified Stokes equation for settling velocity. And this equation nu is coefficient of kinematic viscosity, and dP will be, this is valid for the diameter of particle will be less than 0.1 mm. Okay. Now this equation is called as modified Stokes equation for laminar flow. This equation is called as modified Stokes equation for laminar flow, where Vs will be in meter per second, dP will be in meter, G will be in meter per second square, and nu will be in meter square per second. You have to be very careful, you have to be very vigilant about the units given in the question. Vs has to be, you will get in meter per second, but you need to put the dP in meter, G in meter per second square, and nu will be in meter square per second. Now in this process, we have seen that the viscosity data is given nu, and you are going for the modified settling Stokes equation for settling velocity. अगर टेम्परेचर डेटा दिया हुआ है, विस्कोसिटी डेटा नहीं दिया हुआ है, then what you will do? Then another equation will be used, that is Vs will be equals to 418 418 into g minus 1 dp square into 3t plus 70 by 1000. 418 into g minus 1 into dp square into 3t plus 70 by 100. I think I have uttered 1000. Sorry. Where Vs will be in millimeter per second. Mind it, previously Vs will we are going to get in millimeter per second. dp in meter. Previously here it will be you will to put the dp value in millimeter and T will be in degree centigrade. This particular equation is called as Hazen's equation for settling velocity. This particular equation is called as Hazen's equation for settling velocity. Hazen's equation for settling velocity. Now for transitional flow, so that all those equations, laminar flow where dp will be should be less than 0.1. In case of transitional flow where dp should be greater than 0.1 to less than 1 mm, Vs will be equals to 418 into g minus 1 dp into 3t plus 70 by 100. Remember in this equation there is dp square. Here there is dp. Okay. So by this you need to remember this equation, and where Vs will be in millimeter per second, dp will be in millimeter and T will be in degree centigrade. Units are same, and this particular equation is called as modified Hazen's equation for settling velocity. Modified Hazen's equation for settling velocity. Now finally, we are going for turbulent flow. Turbulent flow where dp will be greater than 1 mm, where Vs will be equals to 1.8 into root gdp into g minus 1. That is valid for any unit. And the equation is called as Newton's equation for settling velocity. The equation is called as Newton's equation for settling velocity. So what else we have done for settling velocity? We have seen the derivation process, and then we have seen what is the ideal settling velocity, that is actual settling velocity by stroke. We have gone for the different conditions, and we have gone for the laminar flow condition, and we have seen the equation which is modified Stokes equation for settling velocity. You are going to use in high number later on. 1 by 18 gdp square into g minus 1 by nu. We have gone for another equation, Hazen's equation for settling velocity, then modified Hazen's equation for settling velocity, and Newton's equation for settling velocity. Now, for your better understanding, we have I've noted one. Don't check the solution first. So the solution is given here. Don't check the solution first. I've noted one question. Find the terminal settling velocity of particle of dia 0.02 mm. The specific gravity 2.65 and mu is 1 cp. Don't check the solution first. I'm requesting you note down the question and solve for a minute. Quickly you can solve it. Find the terminal settling velocity of particle of dia 0.02 mm with the specific gravity 2.65. Mu is equals to 1 cp. Have a look. Giving you some time. Don't see the solution. I'm deliberately telling you, don't see the solution. If you're seeing the solution directly, it will not help you in the long run. Diameter of particle given 0.022 mm, which is less than 0.1 mm. Okay. So actually, mu given here. Newton second per meter square is the unit of dynamic viscosity or absolute viscosity. What is Newton per meter square? It's Pascal. So 1 Newton second per meter square can be written as 1 Pascal second. What is 1 Newton? Newton is what? Kg meter per second square mass into acceleration. Second per meter square is already there, so it is 1 kg per meter second. So 1 Newton second per meter square is equals to 1 Pascal second is equals to 1 kg per meter second. And how we are getting new value? It's mu by rho. Kg per meter second by kg per meter cube. From where we are getting meter square per second. Understood? So we know that 10 poise is equals to 1 Newton second per meter square. 10 poise is equals to 1 Newton second per meter square. That is 1 kg per meter second. And 1 Cp is equals to 10 to the power minus 2 poise. 1 centipoise. Poise if it is equals to 1 kg per meter second. So 1 poise is 10 to the minus 1 kg per meter second. 10 to the minus 2 poise is 10 to the minus 3 kg per meter second. And nu will be 10 to the minus 3 by 3 is 10 to the minus 6 meter square per second. Yeah. And Vs will be equals to 1 by 18 gdp square by nu into g minus 1. From here, if you put all those values, 1 by 18, 9.81 g value, dp is in mm given, that's why converting into 0.02 into the minus 3 whole square in here, by 10 to the minus 6 into 2.65 minus 1. What you are going to get? 3.597 10 to the minus 4 meter per second. And the value will be 0.3597 mm per second. That is the first question. Hope you understand that. Clear? Now we are going for the second question. Once again, I am repeatedly requesting you, don't go for the solution. First, you write down the question, try to solve. That's why I'm giving you some time and not directly going to the solution. Don't check the solution. Write down the question first. A particle of diameter. These are the very, very basic questions. Very, very basic questions. But the main point is you need to know the unit conversion and units itself. Okay. A particle of diameter 0.018 millimeter G 2.7 settling from water whose nu is 1 cs centistokes. Find the settling velocity. So 1 cs means 1 centistokes, that is 10 to the minus 2 stokes, that is the unit of nu kinematic viscosity itself. That is 10 to the minus 2 centimeter square per second. As we required it in meter square per second, it will be 10 to the minus 6 meter square per second. dp is less than 0.1 mm, where equals to 0.018 mm. That's why Vs, now you put all those value, you will get the answer in 3 into 10 to the minus 4 meter per second, which is 0.3 mm per second. Now we are going for third question. Find the settling velocity of a particle of 0.018 mm dia G given 10 temperature given. So what we will see, diameter is 0.018. Diameter is 0.018 mm, which is less than 0.1. That means laminar flow is there. So quite obviously, as it is laminar flow condition exists, so eventually uh, we will go for as temperature given, we will go for Hazen's equation for settling velocity. 418 g minus 1 into dp square into 3t plus 70 by 100. But see, here dp is actually given in mm only, and your final answer will directly come as in mm per second. Is it clear? So we have completed our discussion about settling velocity. Next, we'll go for in the next class we'll go for the plane sedimentation process, the type and the design parameters. We'll complete that segment. So once again, I am repeating one part that if you people are GATE aspirants for GATE 2022, GATE news has come just for you people. There is a New Year gift from Unacademy that evolved for GATE 2022 Civil Batch A, English and Hindi both will start from 28th December 11:15 a.m. Subscribe today to this channel. During subscription, don't forget to add the code SEN10, CN10, SEN10. Don't forget to add this code. Subscribe to this channel, and if you don't have the Unacademy Learning app, then go to your Play Store, Unacademy Learning app, and you will get it. You will install it, and you can get an EAC. You can search for the different courses also, and go for Unacademy Plus, and you can get the subscription for that. And in Unacademy Plus, you will get the top most educators of Unacademy for your subjects, and we will do it together. We'll do it better. And once again, don't forget, when you are subscribing, don't forget to put the code SEN10 for a 10% discount you will avail today. Just hurry up, don't get late. Better to start early. So just put subscribe here, use this code SEN10, you'll get direct 10% discounts process. Let's crack it. And thanks for this session. We will meet tomorrow at the same time, and we will discuss the plane sedimentation process details. Thank you.